Hi, we discussed about the acids in the last video. So now we'll be discussing about the bases. So these bases are substances which are bitter to taste. So bases are the exact opposite of the acids. So acids are sour to taste and bases are bitter to taste. They produce hydroxide ion or OH minus ion when they dissolve in water. So there are different types of bases, that are sodium hydroxide, potassium hydroxide, calcium hydroxide, etc. So now we'll be discussing about some of these all of these acids. So first, mainly they produce OH minus ion when dissolved in water. So it is a chemical equation in bases and water. So NaOH plus H2O gives Na plus and OH minus. So here OH minus is hydroxide ion, and sodium ion is produced when the sodium hydroxide, which is a base, is combined with water. So next we can see another example, that is potassium hydroxide and water. So when potassium hydroxide dissolves with water, it produces potassium ion and hydroxide ions. Next, as we saw general properties for the acids, we are going to see for the bases too. So bases are bitter to taste, as we already know. They turn red litmus blue instead of blue litmus red in acids. So there's no change in the blue litmus. So the important note over here is color of litmus changes from red to blue if red litmus is used, and there's no change when blue litmus is used. So next is bases contain hydroxide ion as a negative ion. So they produce it when it is dissolved in water. Then bases are good conductors of electricity. Alkali, the substance, bases are also known by other names such as alkali, but there is a difference between them. Alkali are substances that are soluble in water. So we are going to see the substances which are not soluble. For example, aluminum hydroxide, copper hydroxide, iron hydroxide are also bases but are not soluble in water. So these are not alkalis. So all alkalis are bases, but all bases are not alkalis. So potassium hydroxide is also called as caustic potash. Sodium hydroxide is also called as caustic soda, and magnesium hydroxide is also called as milk of magnesia. It is used as an antacid during acidity, etc. So antacid is a substance that that neutralizes the acidity or the acidic content in a substance. So milk of magnesia or magnesium hydroxide is one such substance. So next is chemical. So we saw about the physical properties of acids. Now we are going to see about the chemical properties of acids. So when they react with a metal, they produce salt and hydrogen. For example, hydrochloric acid plus sodium gives, sodium is a metal, so it gives sodium chloride plus hydrogen. And another example is sulfuric acid and sodium sulfate and hydrogen is produced. Here sodium is again a metal, and then SO2 minus SO3 2 minus is sulfite, and SO4 2 minus is sulfate. So these are the differences between sulfate and sulfite. So here in sulfuric acid and sodium, sulfate is produced. The next chemical property is that reaction of acid with base, which is also known as neutralization. So when acid and bases are combined together, they form salt and water. This can also be written as a chemical property of base. So for example, hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. Next, sulfuric acid plus potassium hydroxide gives potassium sulfate plus water. So these are the two examples of the second chemical property, that is reaction of acid and base, also known by the name of neutralization. So next comes chemical properties of acid. So as earlier we discussed about the neutralization. So here for bases also it is one of the chemical properties. Another property is that when we saw that acid base reacts with metals to give salt plus hydrogen. So here when bases mix with ammonium salts such as ammonium and etc., we get a salt and ammonia. So for example, here you can see that sodium hydroxide plus ammonium gives what so here sodium hydroxide plus ammonium salt, ammonium chloride gives sodium chloride plus ammonia plus water. So the equation is NaOH plus NH4Cl. So here NaOH is sodium hydroxide, NH4Cl is ammonium chloride, which when reacts together gives salt, which is NaCl plus ammonia plus water. So earlier we saw that acid when reacts with red litmus gives no color change, and with blue litmus turns red, and the ulta for bases, when it reacts with red litmus gives blue, and with blue no color change. So these are the substances. These litmus paper is called as indicators. These give us different color changes, etc. Color change, smell, etc. when dissolved in an acidic solution, basic solution, or neutral solution. Neutral solution are solutions which are neutral in nature or do not change color. So there are more than 2 to 3 types of indicators. The first one is universal indicator. It is a mixture of several dyes or indicators to give several answers. So it is measured in the way called as pH, or potence of power of hydrogen, or potence of hydrogen. So in acidic medium the pH is from 0 to 6.99, and in basic medium it is from 7.1 to 14. So pH of 7 is neutral in nature. So this pH ranges from 1 to 4. That is given over here. It is given in many colors. In acidic medium it turns red in color. In basic medium it turns purplish, and in a neutral medium it turns into green in color. So we'll discuss about the other types of indicators in the later part of the video. Thank you. Watch the third part. Thank you.